We're going to learn about the corpus callosum. So the corpus callosum is a large band of fibers that connects the right hemisphere to the left hemisphere. So we learned about this when we went over the anatomy chapter, and here's a three-dimensional version that hopefully you can see where it would be. So sometimes we actually cut this corpus callosum. So if you can imagine going down and cutting this. So why in the world would we cut this corpus callosum? It's used in severe cases of epilepsy. And what epilepsy is I'm going to act it out so you can kind of imagine it. But this is my definition here, just off the top of my head. A disorder where neurons fire when they're not supposed to be firing and cause a disruption to the brain. So here's the way that I act it out in class is imagine your neurons are firing at a certain rate, like this. But then all of a sudden, we just don't quite understand why, but there'll be like an epileptic focus, and this cluster of neurons will start firing for no reason out of sync. And by them firing out of sync, their action potentials transmit to other areas of the brain. And if the epileptic focus is large enough, then it can cause a grand Mal seizure. There can be petite Mal seizures where just few neurons are being activated, and a grand Mal seizure is the ones that you probably have seen before where they have convulsions and they shake and fall on the floor and so on and so forth. So under this link, there will be a epilepsy. Well, in this module somewhere, I might put it at the bottom, there will be an epilepsy video where you can get more information. But right now, I think I want to go on to preparing you for the great video that I have for you after this. So when we cut the corpus callosum, it's called a split brain operation. So one of my favorite videos that I show you in this class is coming up in this module. And even though this video is old, to me, it's one of the most fascinating things that I can show you. So there was a man, and you're going to see him, and he had a split brain operation to control his epilepsy. So first of all, in my class, what I have them do is I'm like, hey, can you ask your neighbor or something to borrow a pen, and can you guys get out 2 pencils? And I want you to put one writing instrument in one hand and writing instrument in another hand, and I want you at the same exact time draw a circle and a square. And so we all try that. And most of us cannot do it. Maybe you have 2 writing instruments. And so you put one in one hand and one in the other and try to make a square with one hand and a circle with another. It's probably going to be pretty impossible for you. But this guy that has the split brain operation, so his corpus callosum is not allowing his right hemisphere and left hemisphere to talk to each other in the same way that ours is, he can do it perfectly. You're going to be blown away. Now, in the next video, we will watch the results of special testing in a split brain patient. So he had a split brain operation when the video was done about 15 years ago. So now I think that video is pretty old. It could be way back. But again, I've looked, and this is my favorite one. So when they do this testing, you need to understand how the eyes are set up with regard to the hemispheres. So we know that his corpus callosum has been cut, but now let's look at the eyes. So I want to warn you, in my face-to-face classes, we usually have to go over and over and over this. So I'm going to try to do it as simple as possible, but if you don't grasp it, please don't think you're the only one, okay? So each of your eyes, or the retina/retina, is split in half. So, for example, the right eye doesn't just see the right visual field, and the left eye does not just see the left visual field. But basically, your eyes are cut in half. So the right half of each eye sees your left visual field, and the left half of each eye sees your right visual field, because we see everything upside down and backwards. So then the next question that I get is why? And we don't know why. That's just kind of how the visual system has been set up. And since you were born like that, you've just adapted. So let's do this now. Okay, the right half of each eye goes to the right hemisphere. So right goes right. Let's just get that down. Then the left half of each eye goes to left hemisphere. So forget about the visual fields right now and just go left goes left. Left half of each eye goes to left hemisphere. And right half of each eye goes to the right hemisphere. We can do that. Right goes right, left goes left. But now we have to add a second thing. Right goes right but sees left. Left goes left but sees right. So the left half of each eye goes to the left hemisphere, but it sees the right visual field. And then the right half of each eye goes to the right hemisphere, but it sees the left visual field. Okay, let's see a picture. So that was your verbal explanation. So your left hemisphere was very happy. Let's go to the right hemisphere now. Okay, so here's a picture which your right hemisphere should be a little bit happier with. Okay, so let's look at this. Left half of each eye goes to the left side of the brain. And then the right half of each eye goes to the right side of the brain. That's so easy. Left goes left, right goes right. But then we have to remember that we see things upside down and backwards. So the left half of each eye sees the right visual field. There it is in green. And then the right half of each eye sees the left visual field. Okay, so left goes left but sees right. Right goes right but sees left. So you say, Amy, why are you making a big deal about this? This is a little bit complicated. Because you will not be able to understand this next video that I think so highly of. Okay, so, oops, sorry. When the words are flashed to the right hemisphere, okay, so we got a split brain patient. And what they're going to do is they're going to flash the words on the screen. And so when they flash things to the right visual field, which hemisphere is it going to go to? It's going to go to left. So the left can read it. So when they flash a word to the left, he just reads it. But when they flash the word to the right, oh, I messed up. To the right visual field, sorry about that, right visual field, it goes to the left hemisphere so he can read it. But when they flash things to the left visual field and it goes to the right side of the brain, he'll say, I didn't see it. I didn't see it. Now, that in and of itself is really interesting. But then what they're going to do is they're going to ask him to draw it. And guess what? He can draw it. So he can't communicate verbally because remember, your verbal skills are mostly in your left hemisphere. But he can communicate in art. So you're going to see all kinds of experiments that show that. But now, this is the cool part. Well, that's really cool right there. That just blows me away when I watch all those experiments. But then what they do at the very end of this video is they found this really cool artist called Arcimbaldo. Sorry about that. And Arcimbaldo, what he does is he makes faces out of different elements like fruits or books or vegetables. And so if you remember, which side of the brain has facial recognition? Is it the left or the right? It was the right, right? That's why I say please be sure to have the main functions of the right and left hemisphere visible to you when you watch the next video so that you can understand how amazing it is. So when they flash the picture to the left hemisphere, I'm sorry, to the left visual field, and it goes to the right, what do you think he's going to see that picture as? You'll see. And then when they put it to the left visual field, which goes to the, left visual field goes to the right side of each eye, which goes to the brain. What are they going to see? So I hope I haven't screwed this up because sometimes I get kind of wonky in my right and left hemispheres, but I think you guys will understand why you got to pay attention to this next video, and I think you'll understand that when you show things to the left hemisphere and you show things to the right hemisphere, that he gives different answers because they're not connected with corpus callosum. But now, just one final thought before we move on and see this video is how many times have you felt a bit conflicted Like one part of you wants to do one thing, another part of you wants to do another. Maybe sometimes you say, I can't put my finger on it, but something's not right. It's just not right, but I don't really have the words to describe it. So maybe watching him might give you some insight to maybe some of your behavior.